name is Jason Clark. I'm from GA Fleet Technical Services, and today we're going to do some training on a fire pump system. So the first thing we're going to do is, like I said, point and shoot. So we'll start with simple stuff. So suction side is here. Suction side, we'll just go through the fire pump stuff and we'll come back around again. For indication that is your OSMY. You always have an OSMY on your suction side, open yoke, and stem. Okay? So the actual stem extends past and then gives you the indication, and then it's actually more close. You have tamper-proof switches installed and everything anyway by code, so that's all monitored. If anybody plays with the valves, you'll see that happen. So like I said, suction side, we'll follow it back down again. You have an eccentric reducer in the fire pump. You have a gauge that does read 0 to -14 in case you start drawing a vacuum. On your fire pump yourself, then you have an automatic air vent. On the other side, you have a discharge gauge. You're going to have to walk around in a second. You have a discharge gauge on this side of the fire pump, and you have a casing relief valve. While we're at the casing relief valve, I'll just quickly give you an indication what that does. When the pump is running, for whatever reason, this is discharging water, approximately a hose bib's worth of water. We always have it discharging for 2 reasons. One, when you're actually running the main relief line, which I'll explain in a second, you build excess pressure, so it reduces that excess pressure building up. 2, if your pump's running in deadheading for whatever reason,
it's water.
Then you have water moving, so you're not actually deadheading the pump. Because if you have that closed down until it hits a certain pressure, then you could potentially deadhead the pump for a while. So that's part of the reason why we have it set that it will always discharge a small amount of water. Also why it's piped to a floor drain, because it will discharge water. While we're on the subject of pipe to floor drains and everything else, I'll come back around here again. I'll actually tell you what, leave that is fine. We'll do this first. So then what I said earlier on is your main relief line, which is this line that goes up and comes back in. It's a recirculation line almost. So what this does is it's set during the flow test. We set this up to anything, in this case it's written on above 160 psi, gets recirculated back around again to the suction side of the fire pump. So anything in excess of 160 is going to come back around again. And like I said though, you're increasing in your suction side of pressure, that's why the casing relief is also discharged. Because you consistently doing that, your suction pressure is derivative to your, well, it's not directly derivative, but it is derivative to your discharge. It will slightly increase. So that's part of the reason why that's there. All these PRVs, this one, and the casing relief are set by us to flow test. They will only be changed by whoever the qualified engineer you bring in, or sorry, technician you bring in to do the work on the fire pumps. So when you do your annual tests every year, if they need to adjust them, they'll adjust them. Otherwise, they stay as they are. Do not touch. In the fire pump system, everything's set up that you should not have to touch anything, and if there's a false start, the only thing you really should have to do is hit the stop it. But I'll get to that when we get to the controllers. The other thing I said was you got an automatic air vent. When the fire pump's running, the reason we put the elbow on is just every now and again when it discharges air, it might spit a little bit, so they just don't want to shoot up into the room because there's pressure in it, so it just shoots the water down. It doesn't have to be piped to the floor drain, that's fine. Your packing, which you will have to come on here for, you can stand here and I'll stand on this side and run through. Your packing, which is here and here from the front and back of the fire pump, where those bolts are, is meant to weak. You will see a little drip consistently. Don't tighten it. When it's running, like I said again, if you're doing a test, if you find it's streaming too much, you can call on the guys and we can adjust it for you, or we can do it, but you want to have a little bit of water going through it to keep the packing cool when the fire pump runs. And that's part of the reason why it is also piped out to the floor drain. There's meant to be a little drip. That's why you have both these brass pipes going down and they're teed together. That's fine. To the floor drain.
Just make sure that
so
the little hole is clear.
There's always a little bit of drip. Yeah, so I mean, if you get any crap building up in this as well, just make sure you clean it.
Yeah.
If you need to, but obviously don't stick your fingers in and use a roller.
No,
this thing runs. With that in mind, you are going to have water. If you tighten that up, or someone else tightens that up, and this thing does run, it'll burn the packing up. And when it burns the packing up, there's a room that gets filled with black smoke. It heats up and it can actually go on fire. The packing can go on fire. So what we have then is from that point, you also have indications of your system. While we're here, we'll run through it, but one way you always check the fire pump is installed correctly and working correctly is that your suction side is always bigger. It's fatter on this end than it is on the discharge side. You have an arrow on the top for rotation as well, so you can check rotation, but it is going to be monitored. If anything changes for whatever reason, you'll see that happen. Yeah, that's what I'm saying. It's fatter. See, it's fatter here, and you look in here, it's supposed to anything. That's how you tell it's actually running the right way, correctly. So. From the discharge side, you have a concentric reducer. Okay, which is in here. So your eccentric, as you can see, angles up. the water supply in, and your concentric is just a circular out discharge here. You're discharging into your main system check valve. Your main system check valve, you have a test header set up here as well for local testing. You have this little system here with the brass, that's your sensing line. So that's like what we had on the booster pump downstairs, but we're going to run into that a little bit later. Next step as well is then you have your jockey pump discharge into the system, and you have your isolation valve. So that's your main discharge isolation valve. So if you ever need to do any service work or anything on it, you'd be closing this down and closing that down. No, I mean, it wouldn't be you again, it would be a qualified fire technician. But one other thing you do have, in case something goes wrong with fuels here or whatever, you have a street bypass line, which is what this is. It's just street pressure. You've got two separate isolation valves and a check valve. The reason you get two is just to service the check valve. That's it. That should always be open anyway, because that's in case the fire pump fails. If your fire pump fails, or you're doing maintenance work, you got to shut down your fire pump, at least you get street pressure to the first couple of floors. That's what it's there for. It's not going to feed the building, but it's something. Because that's where you're coming out of the building anyway. So at least everybody can get that far, they have a couple of floors of fire protection. That's why it's set up like that. Your discharge side, like I said, then you're wearing your sensing lines. So we'll just follow the sensing lines. So we've got to walk around again, guys. And the orifice is installed here. So the orifice inside of that has a 332nd hole in it. And that's just to restrict and monitor the pressure correctly, so you don't get this massive like swing drop and call a fire pump on. So you can see it gradually go down, gradually go up.
So that's the sensing line.
Yeah, if you follow the sensing line, I just want to explain to the orifice, but if you follow the brass sensing line across, it now comes to the top of the side of this panel. Now, in the side of this panel, you have the same, and it's all screwed in, so I'm not going to open it up, but you have the same style, very similar style, just different manufacturer pressure transducer. And they do give you like a little valve for doing the drop test, which is actually getting the fire pump to run in auto. You can drop the water there. Again, you have another orifice there, I assume, because you should have two. So what's happening there is that's what then goes into that diaphragm device again, and that gives you your digital readout pressure up there, which is 187.
187.
That's what it is at the moment. Okay? That's what that's coming from. So that's where that's being generated. It's being generated right there. Now, mechanically installed, installation-wise, while we're here, we'll look at this as well. Your pumps need to be greased, like I said, or you're on every 6 months. The main thing with a fire pump room is a visual inspection. Like when we get to the controller, I'll run through it all. You have monitoring equipment that's being monitored by your fire alarm system, monitoring the pumps running, everything else. Those are types of things that'll be your front desk. So if anybody gets an alarm with the fire panel, they need to contact you straight away because it could be the fire pump. It's a quick glance, it tells you on the screen. So it's all stuff that you'll have there. Questions? Have you got anything in the mechanical installation?
So here we grease.
Yep.
Right there. Yep. The same, and you have the opening in the bottom.
Yep, and there on that side.
There,
the motor doesn't actually seem to have grease bolts. No, the back. It usually does. No, these ones don't. Some of them do, some of them don't. A lot of them self-contained. But your pump is there, so that's it. And again, it's just regular pump motor grease. It's nothing fancy, high-end that you have to buy anywhere. Like I said, every 6 months to a year, we recommend you do these. I know I said 6 months originally, but 6 months to a year. Because they're not technically running all the time. That's why we say the other ones every 3 months, because it's more a case of the other pumps are running quite frequently, they're being used. This thing should only really be running when you're doing your tests.
So you should be tested once a month?
This is up to you on that end. All you have by code, you have to do a flow test once a year. And in regards to doing churn tests and things like that there, it's entirely up to yourself when you want to do that. Pause for a second. One thing if you do want to do a churn test, so that would be like a month, it's like a monthly test, you just want to run the pump, like exercise it almost.
That's what they used to, yeah.
So if you're going to do that, which is fine,
building.
if you want to do it, it's completely up to you. If you are doing it, what I would say is close your discharge valve for your churn test. You've done it before, then you should know this, but closing the discharge valve means that you're just locally circulating water through the main relief line. You're going to be discharging through the casing relief, so you're not going to be deadhead in the system. But while you're doing that, what I do recommend you doing is when we get to the controller, you have amperage, you have voltage for each of the legs. We recommend you record all that, record your suction and your discharge pressures, and every time you do your monthly test, because those will be indications as to when your pump is needing serviced. As those amperages increase, things change. It'll basically be a record of.
That's if I do the monthly one.
If you're doing the monthly test, or you're doing it every 3 months, or whatever it is, because if you do your annual test, you'll get all that in their report. But if you're doing anything in addition to that, we always recommend you record everything. Because it's great to have for going back and saying, okay, we can say that's when the pump started to draw more amperage, started to get the winding started to wear down, whatever it may be. we can work on it.
So the only valve you close for that monthly is the isolation?
Yes, because if you close that one, that's your discharge to the system. You don't want to push the water against your sprinklers.
No.
So you close that valve, exactly, you close that valve, obviously you still have street pressure, like we were talking about earlier on, and then you're just circulating water through the main relief.
Okay.
If you really want to, it's entirely up to you. I mean, obviously you have local hose, but hose connections here, you can do your own little tests if you want. It's all available to you. Information regarding the pump and stuff is all going to be in your reports from the start and the flow test, but the pump motor, pump, and all the controllers have their plates on them, and they're all bolted to it, so it's a case, not bolted, sorry, they're actually riveted to it, so you can't modify them. They're all there, so if you need to look at any information, like for example, we know this pump's a 500 GPM motor pump, we can look at the motor amperage, we can look at the motor voltage, it's all here. And what your system's set up for in voltage is printed on the actual controller in this case, so it's 200 volts, it's a low voltage system. High voltage is 460 to 40, or 440 to 48. Okay. Mechanically though, you got any questions? You happy enough? All makes sense? Perfect. So now we're just going to look at the mechanical for the jockey pump. Very similar setup, basically the same thing. We're just going to point it out to you so you know what's going on. Suction line come in, you trace that pipe back, it taps into your main suction line. Discharge line taps into your main discharge line, as we were showing earlier on. You have, if you follow it again, you have the sensing line for the jockey pump. The orifices and your drop test and everything in there. It's all there. Jockey pump, you have two isolation valves, one in the suction, one in the discharge, and you have a discharge check valve. That's it. There's nothing else in this system. It's a simplified version of this. It's a maintenance piece of equipment. That's it. So it's self-greased, self-contained. There's nothing you have to do with it. No, you don't touch it.
It has the ports.
It has got ports on it, so if you want to check it every now and again, change it out, you're more than welcome to do it. You shouldn't have to, but you can do it. And, I mean, I suppose if you have reports, maybe do it once every 6 months to a year is not a bad idea. If you're doing the fire pump, you might as well just do it anyway.
Yeah,
But you don't have to do it. It's not that bad. I mean, you can just pump it up, give it a couple of pumps till you see the old stuff coming out, and then you can just stop it. I don't think you have to change it as much as you would with the main system downstairs. Again, you have a bleeder on this one. If you lose water pressure, you would drain the system down, but again, that will be something to be done by like a fire technician, so it's not something you're going to have to really worry about. Directional arrows, you'll see two sets. That one is directional flow, the one up here is rotation. Yep, and the one up here is rotation. If you install it the other way, the arrows go opposite. This way, the arrows are both going in the same direction, so it's not a problem. So that's why I show everybody, because some of the guys come in and look at it and they're like, why is one arrow?
It's happened.
It has, and that's why I show you. But like I said, it's a self-contained piece of equipment. There's nothing crazy to go on with this. And again, you tamper-proof switches on that. The only reason we can leave this in auto, like we said earlier on before we started the drilling, is it maintains like a buffer zone above the automatic start of the fire pump. And that's what it's there for. It's not going to save the building. It's not going to do anything. It's not going to save any lives. It's there just to maintain that buffer zone. The fire pump is your actual life saving. Pardon me. And as I was saying earlier on, those things are designed to run once. You know, it's life safe to get everybody out of the building. It's not to save the building, it's to save the people in the building. That's it. So.
With all that water, it's not going to save the building.
No, it doesn't. Exactly. It's not designed to. There's never, in the history of New York City, there's never been a fire pump that saved the building. It's as simple as that. All right, so we'll go on to the controllers for the jockey pump. Jockey pump controller is the easiest one to look at first, so we'll start with it simplified. So first off, you have your isolation switch again, kill power, same as every other isolation switch. It still leaves it hot at the top side, but everything down is isolated. You have a HOA switch, which you hand off auto. If for some reason this gets broken off and you're in dire need to switch it on and off, you can use a number 2 screwdriver actually. It is designed, you can wedge a screwdriver and actually adjust it that way too. It's just because it has happened before where it's been broken off in the hand position or something, so they need to be able to switch it off, so they made it as like a feel safe that you can use a screwdriver in turn. Control-wise, there's a couple of things that, well, there's one really thing that's worth looking at, but there's a couple of things worth knowing anyway. Ready is just telling you your actual PSI in the system, your pressure. Your start pressure, 165, and your stop pressure, 175. We write it up here so that it's actually there as well, just in case for some reason we lose any data. Exactly. It also means we know that that's what it was set for. Because somebody can change this, I can't, you know, it's permanent marker. Silence alarm isn't really a big thing on this because if you get an alarm, there's something you need to be looking at, yeah. The one thing I want to show you is your good time and date stamps and everything else. You can actually go, if you hit the enter key, brings you into the main menu, you have an event log. If you scroll down the event log and hit enter again, this thing records 3,000 events.
Holy shit.
Now, here's the fun bit. Every event is on an hourly basis. So every hour this records. If something happens, the pump starts to run, it starts to record it every 20 seconds. So this is actually a way of proving if someone's been tampering with equipment, and also a way to see what actually started the fire pump in the first place. Now the jockey pump has this system and the fire pump has this system as well, so you can cross-reference it. But like I said, when the system's running, it's doing it every 20 seconds, so those 3,000 events quickly get used up. But on a normal day-to-day, it'll do a pressure log every hour. It'll just stamp it, as you can see there.
So when that turned on, it should be logged in then?
Well, the fire pump will be locked in the fire pump controller. The jockey pump's the jockey pump. So you just use the both of them to correspond with each other and cross-reference. This one's the jockey pump, so every time the jockey pump runs, so for example, put it back, go into this event log, pressure delta shot up, main switch in auto, leading mode off, manual, all the things I just did.
2 days ago we were doing that.
Yeah, but that's what I mean, it did all that. That was me, just by flicking it. So every time you do anything, it'll do that. As you can see, the timestamp changed every 20 seconds. That's what happens. So it's worth knowing you have that. To get to that, it's quite simple. Otherwise, everything else in here, you can look at it, but it's all password protected. So it's all set up by the factory and fire technician. So any fire technician you bring in to do any work on this has access to all this if he needs to change anything. Realistically, it's all written up with the FDNY and the DOB, and it's all set up, and that's what it's set for. It's not going to be something that needs to be changed. That's what it's required to keep this building in the occupant safe. But if for some reason they need to adjust like pressure slightly increase, they will be able to do that, and they'll obviously refile everything and do what they need to do from that point. All right. Any questions on this system? No. All right. So now we'll start the main controller. So we'll start with the simple stuff first. First thing worth noting, isolation. Same thing as before, kills your power, down to that, down. Your start button is a manual start. If you need to start it, you can just press start for your test, churn test, start. Stop reset, it will reset any like alarms or anything you get on the screen. The stop button though, with this one, when you're stopping, you got to hold it, and it'll slowly bring the motor down.
Okay.
All right, the emergency stop, you stop it kills power. Normally we say use the stop button, just because, you know, it's when I bring it down, it'll sort of go, you'll almost hear it like, you know, shuddering as it's shutting down. But it's just, it protects the motor when it's a little bit. Stop, but if you come in and it's been running for 24 hours and it's not supposed to be running, you hit the emergency stop. The test button corresponds to a little test feature that you have piped into the system. It's the solenoid, and it will discharge water, just as a pressure drop. I always recommend that you do not use it because it's a small solenoid. When you press that button, if it gets a little bit of debris or anything stuck in it, it'll just constantly. You can plug it if you need to. It's a 1/2-inch plug, but that's why we always ask the contractors to install these test points, because you can actually
do that
and drop it that way. Because you can plug it, you have isolation, you can just see the jockey pump. It's more reliable than a little solenoid valve. And the thing is, though, like I said, if it does happen, just stick it in your 1/2-inch plug and it'll stop. Because otherwise, if it's constantly dripping, your jockey pump's never going to shut off. Back to this while we're here. We're going to use, I'm just going to run through the business. So this is your manual override. So if for some reason all your nice fancy pieces of equipment here don't run, which we're going to get into, this, you pull the pin and press it in, it literally pushes the contactor in, which puts power from here to the fire pump. Bypasses all of this. So in case of an emergency, this thing hasn't started for whatever reason, now it will not,
I can start it.
Yeah, it will not stop trying to start, because it's life safety, and I'll get to that in a minute, but you can manually start it. And all you got to do is gives you the procedure right here, but it's quite literally pull the pin, push it in, this thing will lock in place and hold it in place. To reset, you got to press that out and it lets it back out again. The reason they have the security pin is there when people are in cleaning or storing stuff in here, they hit it, it'll jolt it. And that's why they do that, so that they stop someone doing it. And in case of emergency, it's just a pin, pop, push, done. That's it, it's running. You'll hear it run like a jet. I mean, if you've heard them before, they're like that. The other thing worth noting before we start looking at the actual panel is you do have a transfer switch. For something like that, if that happened, you know what I mean, that's where you have the manual run, you can do that. So anyway, with that in mind, what I'm saying on, you do have an ATS system set up here too. The ATS though is not in use, so you don't have any generator backup power. Okay, so that's why we have this disabled. So it's disabled, it's locked out, you have the key for it, there's no wires landed on this. This panel really just normally monitors the voltage. If you do have a generator, and it still shows you your incoming normal voltage. So your normal source is telling you right now is 213, 214, 313, which matches up what you have up here. If, for example, though, you had a generator, you would see your emergency source, and this would be your pull start for the generator and everything to that effect. and then skip brings you back to normal. If you need to use that for whatever reason, if they do decide later on
To add it
to
to,
add into it in the building, you will have to call one of the fire patrol reps, which is ourselves, will be fleet, because we have to get enable the program again, because right now the program is disabled, otherwise the fire patrol controller will look for the generator if someone kills power. So you'll get a constant alarm here. It's going to say that this emergency switch is off. But the problem is, obviously, we're not using it, so we can disable that, but it's something that's factory level, design level, so it's not a case of something we can give you over the phone, we have to come in and do it. Other than that, though, the normal lights and things, what we're going to do now is we system tree, your system status tree, your controller. So, again, same thing, you have your PSI on the top, you actually have your phasing on this as well, so it says CBA, so your building is actually CBA, which just means your 3 incoming legs are CBA. You can either be ABC or CBA. Your normal power is CBA. It tells you that. So if that changes for some reason, you'll get a phase reversal alarm and you'll see all that. And I'll run through that with you.
normal power CBA.
CBA on the fire pump. Your voltage is red across the top, ABC, gives you it across the top. Amperage, same thing. So like I said earlier on, if you're doing any churn tests or anything to the effect, record your voltage, record your amperage. You also have time and date stamps. And then if you have any alarms or faults, you're going to have them come across that gap in between the average and the time and date status. And you're also going to potentially have them on the system status tree as well, which I'll run through in a second what this is. With that in mind, the same thing as I was showing you earlier on, if you hit enter, you go into your event log,